So, the first property I want to talk about today is this thing here. What does this look like? And we found out that passes through the origin here, correct?
Yes,
So which way does it go? It goes like this. So you've got to make it look like a sine curve as you go around. Now you always put in here, what's the value here? And it becomes always labelled between. We'll do that. What's this interesting about that? It goes through the origin. Does anyone want to comment on what that, some property of it?
It's an odd function.
It's an odd function. What do you mean by that?
That it is rotated about the origin.
That is rotated. It's rotated, it goes through the origin. That's not the odd function. Lots of functions go through the origin. They're not odd.
Yeah. That f minus x equals f minus fx.
Yeah, between that, in that domain there, the f of x and the f of minus x are the same, okay? So the f of x is the f of minus x. So we write that down. The property is if f of x is equal to f of minus x. Is that correct? Minus. Whatever way you would like, not the y value is minus that y value to make it equal. Now, if you've got a cos function, what does cos look like? Like so, right? Now, I haven't drawn it really well. It's probably easy and bad on your book. What's this value here in the domain? Minus 1, 2. What's it go from here to? Now, I'd like you to, there's a variety of ways, and I'm going to have a look at graphical way of doing this. This y value here, let's call it x for want of a better term, and there's minus x. Now, pretty obviously, those two, f of x and f of minus x, are not the same length. That's just looking at it. So it's certainly not this function here, which we would call odd function. Okay. So what is it? What's the connection between here? Is there any relationship at all? I want you to see this part here. This is the f of x. You agree to this? This part, right, up to here. What do you think, and if I just put dot, 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 I haven't drawn it particularly well, what do you think that length there is? From symmetry. That's, I haven't drawn it well, right? Doesn't matter. But that length there, and that length there are equal. And so we'll call this the f of x. Correct? What's that? What's this part here? And if I put it in, I just overlap here. What's that length there? F of minus x. Don't get it all mixed up. I said that length from symmetry, I'm using symmetry, would be equal to that's f of x, that's f of x, up that part here. This part up to the graph is f of minus x. What's the whole lot of that? Well, come on, what's that length from there to there? So you get, can anyone say what that is now? F of x, that, so forget about that. F of x, come on.
Plus f of minus x equals pi.
So you get the f of x is equal to pi minus the f of minus x. Now that, whatever way you'd like to put it, that's the property of this thing. So you've got the property of an inverse trig, inverse sine, you've got the property of inverse cos. When you come over here, y equals, I don't like half truths, right? Y equals tan to the minus 1x. Dumb plugs. Origin, yeah, we know that's the origin. So let's sit down on it. Brilliant. Right.
Less than
Greater than
minus 2. No. On 2. 2. Less than 2.
Okay. What do you notice about that length and that?
equal.
That's a y value. What is it?
Y value.
Think of x values and?
Y values.
Okay. I like life to be what? Simple. This length is equal to this length. So the f of x is equal to what? f of minus x, is that correct? Right. It's an odd function. So 10 to the minus 1 of x is minus 10 to the minus 1 of minus x. Make sure you go, they're the four properties. 3 marks, they give the 1 and the 2 and then possibly right. So you never ever just, as an example, never look there. Fair enough? Just that. You have to look at this. And you can see whether this kid knows any maths or not. Now, just doing Damien's thing over, would you like to explain it to them, please?
Alright, so from the beginning you've got sine with the two separate values. So what you'd first do is expand it out because you know the sine A plus B identity, which is sine A cos B plus sine B cos A. So once you expand that out, you can understand that the sine and then the sine inverse, they both cancel each other out to give you the original value, so you can ignore that. But with the cos, you've got like the cos of the sine of the inverse of it. No, so what you've got to do is you've got to let sine inverse 4 over 5 equal an angle and sine inverse 12 over 13 equal an angle. Then you can use the right-hand triangles to figure out what the cos of that angle is. So in this case, cos of theta equals 3 on 5, so cos this equals 3 on 5, and then similarly you can do sine inverse of that equals that, cos of the sine that equals 5 on 13. Then you just bring all those values back into the original equation, so you get 4 over 5 times 5 over 13.
Now, yeah, that's correct. So you would get 4 marks on this. If I could say a few things what I possibly would do. We've got a red one there. Yeah, thanks. If I just had a look at that there, in this game, I'd sort of tend to do, not what, see how he's left it that, and cos of this, plus, I would prefer, if I could write it up here, always use the word let. Don't use the word remember. I mean, you're not telling the examiner to remember something. No, I'm just not trying to be funny, I'm just saying don't. Anyway, I've never seen remember something, you know? Well, yeah, that's stop. Anyway, you say let. It is the sort of word they use in maths. So you say, okay, I'd say let this thing here and that thing there. Damien knows, but see, he's used this sine A plus B form. Sine A, now this thing here, or if you don't like A plus B, we'll call it theta plus alpha. They're 2 angles, is that correct? This thing here, that is an angle in radius. This, we'll call it theta right, or alpha this is, an angle in radius. Is this clear? That's what I'm letting them be. Damien put them down like this and he kept them there. That's theta and that's alpha. Is that clear? I'd rather say, make life easier, so I would say sine theta plus alpha is sine theta cos alpha plus cos. Damien also said sine A plus B, he said sine A cos B plus, what'd you say? Yeah. Sometimes it's better to do, I think, if we make it easy, sine A plus B is sine A cos B plus cos A sine B. In other words, you keep A, B, A, B. That's the way I'd like to learn that. So sine A plus B is sine A cos B plus cos A sine B. A's and B's instead of, so you've got 3, 4, 5. They come up in some of the harder questions later. You might ask to find what angle. The examiners are not interested that much in saying what theta is. You've got to, sometimes you might just say, well, theta's equal to sine to minus 1 of 4 over 5, and you leave it like that. Is that clear? Particularly in the harder ones when we've got projectile motion. The last thing you want to do is work out half the blooming time to find out what theta is. Does that make sense? You just leave it like that. I'll show you those later. Now the same with this one here. So given any trig ratio, you can find any other trig ratio. If you've got sine theta's 4 over 5, cos theta's 3 over 5, tan theta's 4 over 3, etc., etc. Sec theta is what? 5 over 3. Inverse of cos. So it goes. So you can find any of them. So that's one thing there. So this here is, as soon as you look at these, that is an angle in radians. You get it? That's alpha, that's beta, and get your two triangles out of the road. All of this stuff I put out of the road here and work it down. Does that make sense? I'm not saying he would get full marks for this. I'm just trying to get you to think what they are. Because sometimes some boys mightn't have a clue what Damien's put up here. So you see sine of that, you say to yourself, that's an angle in radians, plus an angle. Sine of alpha plus beta, sine A plus B. That's all it is. You all got that now? Tommy, you've asked us?
Yeah, I got this one out. I just didn't get the first one.
Okay. So that's just dealing with that expansion. What's this one dealing with here? Come on, quick, boys, I want to do some calculus on it. What? Well, again, it's a bit of a silly question, I suppose. But sometimes this might be dealing with, yeah, the properties of, I've just been dealing with the properties of inverse. So I did the properties of inverse, and this one is dealing with these, for one term, yeah, basically the properties of it, also concept of what these things are as angles. Yes? So like Peter's in here, don't put remember, let's solve that. Okay, now this thing here, he's put all this down, he's got the right answer to.
Sine to the minus 1, bracket, sine to 4 pi over 3, close bracket, evaluate.
Okay. If I was going to find that, first of all, you find the sine to the minus 1 of something. Sine to the minus 1 of something is? An angle. What do we put down? I believe. No, not I believe. What do you write down? Remember. Don't put remember, I believe, I think. I said just put let. Peter?
Yeah,
You there? No, don't talk. Now, so theta equals that. You all happy?
Yes.
I'll have a look at this. Sine of 4 pi over 3. Right. What's that equal to?
Equals to sine b.
Well, this is, come on, it's 240 degrees, right? I can't work on these radians, they're a bit hard. This is 240 degrees, correct? What's the sine of 240 degrees? Minus the sine of 60. Yes or no?
Yes, probably.
We all got that? Can we put that in here?
Yes, probably.
Can we?
Yes, probably.
Francis?
Yes, probably.
Thank you. Minus the sine, pi. What's hard about that? Now what do you do now? I don't know. But that's equal to theta. Hey? But I do know the sine of the minus 1 of minus is minus sine of the minus 1. Is that right?
Yes.
So I could take that minus things. Minus sine of the minus. Now this is a trick. Brother's not too good at writing, you know. Minus sine. That's SIN, right? You put the minus outside. Yep. You could do it lots of ways, but go on.
Yeah, well, since we know that like sine is an odd function, can't we know that the minus sine of pi 3 is also equal to the sine of negative pi 3, right? Because it follows the odd function rule. Because it's like minus f of x equals to f of minus x. So then you put the negative in, and then the sine inverse of the sine cancels out, so it leaves you with minus pi 3.
That's right. Brilliant.
Sorry.
It's very good. Yeah, have a look at this one too. You put the minus out in front. We didn't know what he was talking about, did we? No, anyway, no, you're right, Francis. Stop. You're trying, that's right, you're right. But I'm trying to relate it over here, right? Well, the job does done. Sine of the minus 1 of minus a number is minus sine of the minus 1, right? Now this sine of this is root 3 over 2 is 2, all right? Yes?
Yes, well.
If you want to put out like that. Now, when you've got this, what's the value of what we do here? Keep that in there if you like, but if I just took that as it was, what does this become? Sine theta is equal to? Minus the sine of pi over 3. Correct? What am I going to do? You can't have plus and minus. What do I do here?
Take in the minus.
You all know that the sine of alpha equals sine. Forget about inverse. Don't you know that sine curves, right? You've done sine curves, have we?
Yes, brother.
Yes, no? We all know that sine curves, the sine of alpha is minus the sine of minus alpha. Isn't that the function? Minus the sine of minus alpha, or plus that is whatever. The sine of minus alpha is equal to minus the sine of minus alpha. Yes? That's an odd function. So forget all the rest of it, just concentrate on this part. So I could put minus the sine of that is equal to the sine of minus pi over 3 because of that. I'm not cheating going from there to there. Minus sine of that angle is the sine of minus the angle. Correct? From that graph. That's the graph of it. And I don't know what this means. What's POT? What?
Pure I.
POI. Where'd that come from? Make it up, didn't you? Even in Russia they don't do that. What?
I don't know. Done it all over to you. So.
You have. You can start your own book, isn't it? Well, you don't know. Well, I've never seen it in my life, but anyway, no, we don't think that solves that problem. We all know it's a point of inflection, right? It's like saying they're the axis, you may as well sort of put axes on. Right, well, you'll be going to Christmas time putting, is that right? There are a few things about here. This would be as hard as you'd get this graph. That's as hard as you would get. Okay? So, first of all, you've taken this value here, cos the minus 1. I'd have to see what you've done. Is that correct? Did you put the 2y and the minus over here?
I normally, because cos inverse of anything is between 0 and pi, and then I times in half, and then minus half, and then replace that with.
All right. So here's a variety of ways of doing it. Okay. Another way I've been telling you is this. I'm not saying it's wrong, but just trying to convince everybody else. If you've got 2y equals cos of minus 1 of 3x, I put it in that form. I know what he's done here is correct, but I would prefer you to sort of say, okay, the domain is general, because this fits everything, right? The domain is 3x is between
-1 and 1.
minus 1 and 1, correct? The range is whatever it is, the range. So y values in this case between 0 and 1. Now, I think if you do it that way, you'll get the answer, because we do it always this way. Now, I'm not suggesting this is a wrong. Clear? So I would like you to have another go at this one. That is important. We won't have time today. We'll put that down. That's the right graph. And but see, it's all. You must remember, boys, in maths, there's a whole variety of ways of getting an answer. That's correct. And I can't argue with that. I'm just saying, any problem you get, if we have a structure there, follow the structure, you get it out. That's what I'm saying, for example, in, you have a non-induction, you don't? You have. In the mathematical induction, you follow a structure every time. Bang, 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 bang. You know, probably Sir did the same thing. And I just like using the word step. Some books use it, some don't use it. I couldn't care less, but that's what we'll do. Clear? So you have certain HSC, we'll just bang, bang, bang. Right up? Sine to the minus 1 of x. And then I'll work out how we find this. By the way, never use y dash. Who uses that? Well, if you do, you don't get any marks. Why not? Because they might ask the question, y dash equals y. How would you solve that? Correct? Now, in anything in this stuff here, and this is why, look, if I said to you this, I'll do something different, right? I used to ask these ones. What's that? Oh, circle. Is it a circle?
Yep.
Rubbish. So they reckon that's a circle. How do you do that? You say to yourself, I'll differentiate both sides with respect to x. Y equals that. dy dx. You differentiate that side. You differentiate x squared with respect to x. You differentiate both sides with respect to x. Say that?
Differentiate both sides with respect
So
to
I
x.
differentiate x squared with respect to what? Differentiate y squared with respect to
X.
I can't work this out. I differentiate 4 with respect to x. Is this hard? Yes. What's respect to x is to differentiate y squared with respect to y dy. We've got to use this a lot actually. Have you done that before?
Yes.
Have you ever seen that before?
Seen it, but never did it.
X. Now, you know how to do that, but you don't know what how you're doing. You don't know what you're doing. You'll say, you'll know the mechanism. But if I asked you to say, how did you do that, you'll say, it's in the book. It's got to follow here. It's an X. How the hell do you get X out of this? No. Well, come on, how did you do this? Come on, tell me. But why did you do it? You say, it's 3 brackets, x plus 7, and you take 1 from it, and you differentiate the part in and you get 1. Is that correct?
Yes.
But why did you do that? How did you do that? This part, is so if I said, if this part was u, you get y equals u cubed. You differentiate y with respect to u. Is that right?
Yes.
And you differentiate u with respect to x, which in this case is 1. And the rule is that dy dx is dy du by du dx. This is the most important. I don't care what you did last year. It doesn't interest me one scrap. This is right. Now the teachers tell the kids in all schools, oh, forget about this stuff and just do it. And the kids say, oh yeah, it's only nothing. I've got no idea what's going on, but I'll do it. And I could show you how all this works, and we'll prove it too. Understood? That's, if you go to uni and do maths and next thing you don't know this stuff and don't even know how to prove it, so that's another issue. So you see this part here is your u. You differentiate u with respect to u, you know? And then you differentiate the part inside the bracket. That's it, that's what that is. Let's take another example. Y equals, say something, you make it
2x
something.
plus 7, 2x.
2x squared plus 7. Huh?
Yeah.
To the power of a third, right? Make it harder. You couldn't differentiate that. So what you say, what you did, Sir said last year, it's 1/3 brackets 2x squared plus 7. Then you take 1 from the power here,
Negative 2 over 3.
and then you differentiate this part inside here and get 4x. Now, that's what he told you to do. That's 100% right. But what you're in fact doing is using this rule. That's what you're doing. It's all right saying, teacher, you can get the kids there, multiply that in there, take 1 from the power, and then differentiate what's inside the bracket, and that's the answer. Absolutely 100%. But the question I'm asking is why you do that. How do you do it, and why do you do it? And you never probably ask. You never ask the question, well, okay, so what the hell, how did you do that? I understand that, but that, we've got to know that relationship here. And what you've done, this is a variable on its own. That was your u. So you differentiate u with respect to u. U, and that's where we got 1/3, this is the u. And then you differentiate the u with respect to x, and that's where you get the 4x. That's the chain rule. I know this might be going a bit fast, and they're not going to ask you to prove it, but that's what you're doing. Clear? You've got 3 variables. And we're going to have 3 variables all the time. Differentiate x squared with respect to x. So that differentiate x Differentiate y squared with respect to x.
Differentiate y squared with respect to
This
x.
function here is called
Equation.
what type of function?
It's not a function. It's a relation.
No, it's called an implicit function. You heard that term? Implicit means, explicit means y equals, you know, y equals y. When they've got all the y, x's and y's mixed up, they call it an implicit function. And you can differentiate it implicitly, is the word they use. In other words, some kids would put down over that and then take this plus and minus, the square root and all that stuff. We're just doing it here. The differential of that is 0. Now, the differential of y squared with respect to y is 2y by dy dx, and the answer to that is 0. You put the dy dx, 2's cancel out, and you end up getting minus x over y. And the fact, if you know what the point is, x, you know, the point's got an x value in it,
Y value.
So some value on here, you just put it, you can find the slope. That you don't make it an explicit function and then find y and then use it. It's differentiated implicitly. But why I'm using that, because this part here is the chain rule. All right? Differentiate sine y with respect to y. And what do I end up getting? Cos y. Now, I'm going to show you this. If you've got dy dx, dx dy is that, I can find dy dx is equal to 1 over that. In other words, if you've got dy dx, you use, you can, yeah, it's dx dy is 1 over dy dx. It's clear? Do you follow what I'm saying?
Yes.
What am I saying? That you, that if you've got that, and that's what we have a lot, as you'll see as we go through, right?